This lesson introduces class and objects. It will be a brief introduction to object-oriented programming. Let's look at two important concepts of object-oriented programming. First one is classes. Second one is objects. Let me begin with very simple objects, something you are already familiar with it. So if you look at shape here, we have lines and then ovals, rectangles, and different shapes. These are all software objects. So let's say a line, we have an oval, looks like a circle, and rectangle. These are software objects. And then minimize and maximize and close. Those are behaviors belongs to window object. So let's look at more details. Lines can be small or long, or short and long and medium. So it depends on what we call as a length or size of line object. Sometimes we use some sort of measurements in practice or in real world, say 3 centimeters. Next one, we make a decision for the circle or oval size, depends on radius. For example, 1 inch, or when you're dealing with the pizza applications, possibly a small, medium, large size, depends on radius. Here we are looking at a rectangle object. So it depends on size here, width and height. So all these things we representing as states of objects. So when we're talking about objects, we can identify 3 important concepts. One is states. Next one will be behaviors and identity. Let's look at states here. So we have 1, 2, 3, 4 different states, depends on types of objects. That is usually defined by data type. Next one, we are looking at another characteristic of objects. Depends on behavior. We can say smaller or bigger. That may apply to any other objects, length or oval or rectangle. So behavior. Again, some textbooks say states or properties or attributes. Basically same thing. Also, behaviors known as actions or operations. Again, depends on your textbook. Let's look at the examples of objects. Say object state, then I will say behavior here. One of the examples is window. We have minimize and then restore and close. That's the behavior. Again, states, in this case, we can identify that window as an untitled paint. So we need a name of window. Then behavior, minimize, maximize, close, open, new, and so on. Also, we have a couple of other here. Let's look at another example. Let's say you have a lamp on your desk. State is on and off. Of course, behavior is behavior of that particular object is turn on, turn off. And let's look at television. Again, same states, whether it's on or off. Behavior, well, again, we have a volume. And then channel, 1, 2, 3, and so on. The behavior, we can turn it on or off. We can volume up and down. Also, we can change the channel up and down. Those are behaviors we can associate with the TV objects. Ideas are simple. Before you define your own classes, you should be able to identify at least two things, two important concepts, states, and then behaviors. So let's look at objects. How the concepts related to objects can be defined in classes. So let's look at the states. Or you might be more familiar with properties. This is what we call as a data field in Java class. Again, next one is behaviors. They can be defined in Java class as methods. So I try to use the name called data field or data or methods instead of saying behavior from now on. So here, window object. we can define states called name as a data field, and then behavior of windows we can define as a method. For example, if we have a string and name, that's a state. In Java methods, we may have let's say minimize window or maximize window, close, open window. Here, let me just type the name of method only. Next one, we have volume. That's initial value is 0. And then we can have methods that define behavior of TV objects. Volume of int new volume. We may have a different method called volume down. Int new volume. So let me put the comments here saying that class is template or blueprints or contract for objects. Sometimes we say class defines the states and the behavior of objects. And then when you're looking at objects, object is an instance of class, depends on template, blueprints, and then here define states and behaviors for objects. So window object, we have a class name called window. Again, it should be capitalized W because class names start with or begin with capitalized W or capitalized character. And the object name lowercase. We may have a different object name, but here I will say window object. That's the object name. In our examples, we may have line. If you look at the picture right hand side, oval or rectangle classes. So according to my diagram, we have a line, oval, then rectangle classes. For the objects, of course, you can have whatever you want. You may call it as line object or oval or rectangle objects. Let's look at the definition of objects. Say object is an instance of class. Also, object represent software entity uniquely in the real world. It means that when you construct objects based on class in your memory or in your computer memory, there will be multiple objects, and then all objects will be identified with a unique value. So that's what we call as a unique ID. So in this case, look like this. You may have a rectangle, small and medium or large. We normally name it as an object reference variable, or just simply say we name it. Here, each object reference variable based on rectangle class will be located in memory with a different address. That's what I mean by software entity is uniquely represented in the real world. Let's create a new project to quickly demonstrate how to use classes to construct objects. Try not to create a main class. I'm going to use one of the examples. Let's look at the first object called line. Instead of using oval or rectangle, so it's identical or it's exactly the same idea. So let me start with the first one. Java class, you name it as a line. Make sure L stands for line class name, capitalize it. I will say line class. So line class, we are looking at representation of objects. So we want to set up blueprints for line object. First one, we are going to define data field. Happen to be there is only one. Again, data field define states of the line object. So here we have a double length 0.0. So line object has a length. So for example, 3 centimeters, 10 centimeters, and so on. That's all you need for line class. That's it. Let's create actual applications. I will say line app stands for application or line application. It will come with a main method so that we can actually run our applications. So we know that the class constructs objects. So we are looking at here, class is a template or blueprints, or object is an instance of class. So we are going to create an instance or object. It's actually same thing. People like to use the same name again and again. So how do you actually create an instance of the class? We use the class name. And then we use a new keywords or new operator with a class name. That's what we create as actually constructor, but we will cover that later on. Again, the first one we say line, and then object reference variable, line, lowercase. Maybe I'll change to line, small line, equal new line, and then close it. So using new operator with the name of the class called line and open and close brackets, that's what we call as actually constructor. I will cover it later on, don't worry. For now, we say that we have a small line object reference variable. We learn it. So you can see there's the name of the class at some unique ID. Again, that unique ID exists in Java virtual machine, saying that we have one object. So let me have one more. Say a longer line. Again, I will copy paste it. So we construct two objects based on the same class called line. If we try to print name of the object, it's going to return unique ID. Again, unique ID, two of them based on line class. Those are actually located in Java virtual machine. So at least the second statement makes sense now. Let's look at the line class so that we can change the behavior of two objects called small line and then longer line. So if you look at it here, we can change the behavior of a object. It means we need to have a method in line class. Again, actually implementation is as methods. So I'm going to have two methods. One is public, void, set length. Again, data type should be double. I will say new length. Length equal to new length. So I can assign new value. Also, I like to know the size of a line. So we'll say get length. Return type is obviously double. So length will return new value, or the actual data value also should be the particular line object. That's it. So go back here. Let me focus on the first object. We can set new value using methods. That's how, what do you mean by we can change the behavior object using its own methods. Using dot operator, it's going to bring you a list of methods. This time we are going to focus on set length, change to 1 centimeters. Then here we can use the dot operator after object reference variable we bring it up the method that associated with objects. It means that small line dot get length method is exists in line class, because small line and then longer line, both objects are instance of line class. So here, this time it's going to show us the actual value inside the line objects instead of unique ID, because we are not looking at objects itself, we are looking at the values associated with the objects. So we have 1.0, default value 0.0. So let's make it something more appropriate for longer line. Set the length, say 10 centimeters. So when you print it, it's going to give you 1.0 and 10.0. Okay, now that's the overview of class and then objects. So you can define the class, you can construct the objects, you can change the behavior of objects using its own methods. So let me visualize it quickly. So we have object reference variable based on a class. Of course, class has a name, for example, line. Let me use the generic name, object reference variable. That's a class, or name of the class. Inside the class, we have two characteristics we can define as a data field, one of them. Second behavior, we can make it as a method so that we can control behavior of objects. So that's what we call it as a class design. Based on line class, we can have an object diagram. So I have a big rectangle outside my reference. So here, small line, that's the object reference variable. And then line has one data field. So let me say line class. We have length. Just say a length. Normally I put the variable name and then small rectangle with value in it. So I'm going to put 0.0. And then in our example, we have two methods, set the length and get the length. So if you want to change states of this line object, we can use set the length methods so that we can make it bigger or longer line. And if you want to print it out, of course, you need to access actual value inside the objects. We can use a get the length method later on. So here I will say 1.0. So if you want to print it out actual value associated with the small line object, we can access through get length methods. Again, set the length, get length method should be defined in the line class. That will return 1.0. Okay, let me look at here. I will put one comment. Again, these are two methods, set and get length, to define behavior of line object. That's it. I think that's all overview of class and then objects. Thank you.